Good morning, everyone. We are going to continue with chapter number 4, that is advanced structural modeling. In last sessions or in last lectures, we have seen about classes, objects, then we have seen about advanced classes, classifiers, constructors. Then we have started with advanced relationships. Here we have seen about classes, what classes is, what are the objects, what is advanced classes. Then we have seen about constructors, then operations and methods, classifiers. What are the classifiers? Which are they? Then we have seen all the classifiers explanations, their denotation, their representation. Here you can see the representation of all the classifiers. That is class, interface, data type, signal, component, node, and use case or subsystem. Then we have seen the visibilities, that is public, private, and protected. Then their notations, example for the visibility. Then we have seen the scope, that is instance and classifier, class scope and instance scope. Then we have started with advanced relationships. From that, we have seen the dependency relationship, that is uses. Okay. Then we have seen the enumeration. Then we have seen generalization, that is inheritance is a relationship. Then we have seen the specialization also, that generalization and specialization are two opposite viewpoint of concept of classification. Okay, here you can see the example of generalization, superclass and subclass. Subclass is inherited from that superclass, and that specialization is exactly opposite of generalization. Okay, so we have seen that there are four constraint in generalization, that is complete, incomplete, disjoint, and overlapping. Okay, then we have started with link and associations. So we have seen what is link. In exam, there will be question for 1 marks. What is link with example and what is association? Okay, so link is a relationship between the two objects. Okay, link is the relationship between two objects, whereas association is the relationship between two classes. So therefore, we can say that object is the instance of a class, so that link is also the instance of association. Then association is the communication between the classes. Okay, association is the communication between classes. So they can be either unidirectional or bidirectional. So we can show this association using navigability arrow. Okay, so we have seen that every association has a name, then multiplicity, that is cardinality, then qualifiers, aggregation, navigability means unidirectional or bidirectional, then visibility, that is public, private, and protected of properties and methods. Okay, so we have seen that cardinality or multiplicity. Here you can see the multiplicity can be expressed as exactly one, yeah, exactly one, then 0 or 1. How to represent that multiplicity? You can see here. Then many means 0 to many. Okay, or directly star sign or asterisk sign. Okay, then one or more. Here you can see the one or more. Then exact number. We can also give the exact number for that multiplicity, or a complex relationship where if we are having, that is like 0 to 1, 3 to 4, 6 to many onwards. Okay, so this is multiplicity for association. Then we have started with types of association. So there are many types of associations. Okay, so that is qualifier association, then or association, an array association, association class, recursive association, then order association and navigation. So first we will see That is qualifier association. That is qualified association. Okay. So here in qualified association, a qualifier partitions the set of objects across an association. So the qualifier rectangle is a part of association path. Here you can see the qualifier rectangle. Qualifier rectangle is the path of, sorry, qualifier rectangle is a part of association path. Okay, so not the part of class, it is not the part of that class, it is the part of association path. Okay, so the association that continues, that constitutes of a qualifier is called as qualified association. So the association that constitutes of a qualifier, okay, that is called as qualified association. Here you can see that this is the qualifier, job id colon integer, this is qualifier for this class. Okay, so see the association between these classes. Okay, so consider this as a class A and class B, and this is the qualifier. Okay, so this is the example of qualified association. Okay, so here you can say given an object at one end of association to identify an object or set of objects at the other end. Here you can see the multiplicity also 0 to 1. Okay. Then next one is OR association. In OR association, it is the case when only one of the several available associations may be instantiated at one time for any single object. Here you can see there are three classes here: class A, class B, and class C. So either class A is connected to class B or class A is connected to class C. That is OR association. So there are only one of several available association may be instantiated at one time. At one time, that class A is connected to class B, or at class A is connected to class C. The next one is association classes. Association classes. Okay, here in an association between two classes, the association itself might have some properties. Okay, so that may be represented by a class to add attributes and operations to that association. Okay, so a class of this type is the class like any other, and such as it can participate in other relationship within the model. Like if there is a class A is connected to class B, then we are going to add that class C, that is association class. Class C is association class. We are going to add in this relationships. Okay, so an association that contains attribute but does not directly participate in relationships. Okay, so with other classes is called attribute association. This association class is used to emphasize the relationship between two classes. Okay, so here you can see the example, like if in an employer or employee relationships between a company and a person, there is a job that represents the properties of that relationship that apply to exactly one pairing of the person and company. Here you can see there are two classes, company and person. Okay, so the company having employer. Okay, so that employer may be person that is employee. Okay, here you can see the company having many employees. Okay, many employees, one to many. Okay, so here you can see the association class. So there is a job. Okay, so that another class participates in that relationship or in that associations through this association class. Okay, so job, here you can see, as we have seen in this example, there is a job that represents the properties of that relationships that apply to exactly one pairing of the person and company. Okay, one pairing of person or company. Here you can see this is the association class associated with this relationships from company to person. How to denote that association class with that association relationship? Here you can see the dotted line with that two classes. Okay, so this is all about association class. Okay, so next one is recursive association. Okay, so we are remaining with n array association. So here you can see the n array association. It is an association among more than two classes. association between more than two classes. Here you can see the class A, class B, class C, and class D all are connected to each other. That means association between more than two classes here. That is an array association. Okay. So you can take an example of like project, person, and language. Okay, so consider the project is one class, person is another class, and language is another class. So that means these all three classes are connected to each other. Okay, the person having project with, person is doing the project with the language. Okay, so for that, next one is recursive association. So there may be questions for all these associations for 1 mark in exam. Okay. So what is recursive association, or define recursive association? So it defines an association from class itself. Here you can see the association from class itself. That is recursive call. You have studied the concept of recursive. Okay. So here you can see the class is connected to itself here. That is recursive association. It is possible to connect class itself. Okay, it is possible to connect a class to itself. Here you can see this class A is connected to itself. The association still represents a semantic connection between objects, but the connected objects are of the same class. Okay, so there may be, it may be possible that the objects of the same class may be connected to each other, but it should be from the same class. Okay, so see the recursive association here, representation of recursive association. Class A is connected to itself. The next association is ordered association. Okay, ordered association. In ordered association, it is used to represent links between objects. Used to represent links between objects which have a specified order. Okay, so like consider the example for class A and class B. These are the two classes having some objects. Okay, so we are going to connect that objects both that are having specified order for execution. So that is, here you can see the role ordered. Okay, so class A and class B is connected to each other with ordered association. The next one is navigation. So in navigation, it is used to mention the direction of association. Used to mention the direction of association. By default, associations are bidirectional. In navigation, by default, the directions are, or that associations are bidirectional. The absence of an arrow implies that the associations may be navigated in both the directions. That bidirectional means that association may be navigated in both the directions. Okay, here you can see the association this is the navigation association. Okay, that means this arrow is navigating from this class to this class, but in navigations this is the bidirectional navigation. Okay, that is this both classes can move from one to another. Okay, here, but this is the association navigation. Okay, here that user class is implies to that person, sorry, password class. Okay, this is the association navigation. Okay, directed association. Okay, direct navigation here from this class to this class, and user is having multiple passwords. Okay, user is the owner of that password. This is the association for that. This is the example of navigation here. Okay, so next we are going to see that aggregation, that is whole part. Okay, so a plain association between two classes represents a structural relationship between peers. Plain association between two classes represent the structural relationship between peers. Okay, so aggregation is a form of association. It indicates whole part relationship. Okay, it indicates whole part relationship. There may be questions in exam like what is aggregation or define aggregations. So we have to state that what is aggregation with their example. Okay, so to model a whole part relationship in which one class represents a large thing, that is whole. Okay, the whole part. that represents a large thing which consists of some smaller things, that is the parts. Okay, so this kind of relationship is called as aggregation. Aggregation is having two classes, that is one is for whole, that means that class represents a large thing. Okay, and another one is consist of smaller things, that is the parts. Okay, for example, car is another class, car is one class, and that wheels are another class. Okay, so that class is larger thing, that means that is the whole. Okay, and that smaller thing is the that wheels, that is for parts. Okay, then this kind of relationship is called as aggregation, which represents a has a relationship. Okay, which represents has a relationship, meaning that an object of the whole has objects of the part. Okay, so that operation on whole is propagates to parts. It may be multiple. That hollow diamond is attached to the end of that path near hole. Here in example, we are going to see that. Here you can see the example for college and department. Here you can see college is the hole and the department is the part. Here this is the hollow diamond. Okay, that hollow diamond is attached to the end of that uh, whole part here. That college is a large unit, or we can say that college is the last thing. Yeah, that college is having the department. Okay, so the department is the part of that college. Okay, so one college is having multiple departments. See the multiplicity here. One college is having multiple departments or many departments. Yeah, the department is the part of that whole college. Okay, this is the aggregation, or we can say, see the this is the whole, what we can say, hollow diamond here. Okay, and attached at the end of that whole class here. Okay, so this is all about aggregation. Okay, so aggregation is really just a special kind of association, and it is specified by adorning a plain association with an open diamond at the whole end. Yeah, like this. Yeah, open diamond at the whole end. Okay, so there are major properties of there are two major properties of aggregations, like transitivity and antisymmetry. Okay, so we will see this. So then next one is composition. So what is difference between that aggregation and composition here? So see carefully here. This is the aggregation, and now we are going to see that composition here. So composition is a special form of aggregation. It is a special form of aggregation within which the parts are inseparable from the whole. Inseparable from the whole. Here you can see in aggregation, this whole hollow diamond is empty. Okay, but in composition, you can see this is the field hollow diamond here. Okay, that school is the whole part. That school is having one department or many department. Here you can see one to many relationship. School has a department. Okay, has a relationship here. School has a department. This is the composition here. Field hollow diamond. You can see the difference between aggregation and composition here. Okay, so as I said, that there are two major properties of the aggregation, like transitivity and antisymmetry. So what is transitivity aggregation? It is defined as if class A is the part of class B and class B is the part of class C, then that class A is the part of class C. Okay, see this carefully, or listen careful, like if A is the part of B. Okay, if A is the part of B and B is the part of C, then A is the part of C. Okay, like see the example, consider one example, like college, department and teacher with aggregation relationship. Okay, so college is the part. Okay, so college, department and teacher. So see the dependency, like college is one class, department is another and teacher is another. So the teacher is part of that department. Okay, then the department is the part of college. All are connected with that aggregation relationship. Okay, so here for department, whole is the whole class is college, and for teacher, whole class is department. In the case of college, the department is the part of that college, and that in case of teacher, the teacher is the part of whole class department. Okay, so that means college is having department, department is having teachers. Okay, so this is the interdependency between all these classes. Like this is the transitivity aggregation. Okay, that means, like, consider the example college. If that teacher is the part of department and department is the part of college, then the teacher is also the part of college. Okay, then next one is antisymmetry. Okay, here antisymmetry is defined as if A is part of B, then B is not part of the A. Okay, B is not part of the A. Okay, so like consider the example, like for composition, composite aggregation or composition means that the part is a member of only one composite object, and that there is an existence and deposition dependency of that part of the composite. Like that composition is denoted by that field diamond we have seen. Okay, so this means that that composite solely owns the part. Like example, if the doctor is only reporting to a particular department, then it is represented like department with a field hollow diamond and part of that association doctor. Okay, so one department having multiple doctors, the doctors are part of that department with field hollow diamond. That is for composition. Okay, so next one is assembly aggregation. Okay, assembly aggregation, when one part is created or constructed by assembling many physical subparts. Okay, many physical subparts, then it is called as assembly aggregation. Here here you can see that assembly aggregation means when one part is created, whenever we are going to create one part or constructed by assembling multiple subparts. Okay, like see here example for, like, computer is the assembly of chips and boards. Here you can see, here computer is created by this assembly, like motherboard, DMA chips, LAN card, etc. parts. There are several parts for computer. We are going to assemble these parts and create one unit, that is computer. Okay, computer is the assembly of chips and boards. Here you can see. So what is assembly aggregation here? Here you can see this is the hollow diamond. Okay, not the field diamond. Okay, so that motherboard is the part of that computer, and also DMA chip is the part of that computer, and LAN card is also the part of that computer. Here you can see the multiplicity here. One computer is having multiple boards. Okay, one computer having multiple chips, or one computer having multiple LAN cards. Okay, it is possible that, okay, having multiple boards, multiple chips, and multiple cards here. Here you can see all that parts, sub parts here, motherboard, DMA chips, and LAN card. These are the sub parts here. We are going to assemble this in one unit for, like, computer. Okay, this is the assembly aggregation, example of assembly aggregation here. Okay, so that assembly aggregation is having multi-level aggregation. Okay, there may be questions for 1 mark or 4 mark, that what define multi-level aggregation, or draw multi-level aggregation diagram for microcomputer. Okay, so what is that multi-level aggregation here? Okay, multi-level aggregation means, consider the example for that microcomputer, that multi-level aggregation is a weak relation between two entities in multiple levels. Okay, so there are multiple levels are there. That means when one entity is deleted, the other object will not get affected. Okay, so there are multiple levels. Like you can see that microcomputer is having, several layers, like a monitor, keyboard, mouse, system. Okay, so that keyboard having some keys. Okay, this is the aggregation. Like microcomputer is having keyboard, that keyboard is having keys, then mouse is having a right click button, left click button, scroll button, then system is having chassis, CPUs, RAM, fan. Okay, so if we are going to delete any part or sub parts, that will not affect on that upper part here. Okay, that is multi-level aggregation. There are multiple levels are there in that aggregation part. Then Next one is realization. So what is realization here? It is a semantic relationship between classifiers. We have seen the classifiers. So it is a semantic relationship between that classifiers in which one classifier specifies a contract that another classifier guarantees to carry out. That is realization. Okay. That means it is the association that connects one class to another class, such as interface class, which shares only its behavioral specification, but not its structure. It shares only its behavioral specification, not the structure. Okay. So that generalization is a relation between two classes at the same semantic level, whereas realization is a relationship between two classes at different semantic levels. So graphically, a realization is rendered as a dashed directed line with a large open arrowhead pointing to the classifier that specifies the contract. Here you can see that example, that relationship parts we will see in the next session. Okay, realization, then interface. Okay, so in next sessions we are going to continue with the realization part or remaining part here. Okay, so that's it for today's session. We will stop here. Thank you.